A complete set of values of p for which this equation describes a circle on the xy plane. So let's go ahead and try and write it in this form here because then I'll have the center and the radius. So we need to complete the square. So x minus p squared minus p squared will give me this term. And then plus y minus 3 squared minus 9 gets me y squared minus 6y. Then I'm just gonna set that equal to p squared minus 8p minus 9, which means x minus p squared plus y minus 3 squared is going to equal 2p squared minus 8p, and then actually these cancel. So there's no problem with the center being at P3. That is not going to restrict us in any way. We're just told it's in the XY plane. There's no conditions like it has to not go into one of the quadrants. You sometimes see that. But what we do have to have is that the radius needs to be greater than 0. You can't, this wouldn't describe a circle if the right-hand side ends up being negative because the left-hand side is necessarily positive. So if the radius is greater than 0, it means the radius squared is greater than 0. 2p squared minus 8p must be greater than 0. And I'm going to factorize out 2p, giving me this. Sketch a little graph of y equals this function. We've got a root at 0 and at 4. I'm plotting y against p technically. This is a happy quadratic. It looks a bit like this. And I want to know where it's positive. So it's actually going to be when p is greater than 4 or when p is less than 0. That will guarantee us a positive radius. And so those are answers. So let's just take a little look. It's going to be answer D.